Friends, in last video we had discussed about the solenoid. Now today we'll discuss about its block questions given at page number 2 to 9. So see the first block question. Consider a circular loop of wire lying in the plane of a table. Let the current pass through the loop clockwise. Okay, see the current is loop, it is the clockwise. Apply the right hand rule to find out the directions of the magnetic field inside and outside. So right hand thumb rule, if you apply here, just to remind, if you keep the thumb in the direction of the current, and so direction of the fingers will show the direction of the magnetic field here. See in this loop here, the direction of the current is in upward direction, so direction of magnetic field, it is from like this. Okay, so here it is upward direction, outside of the loop it is the upward direction. So you can see here the direction is upward here, and if the direction is current is this, so you will find the downward direction inside. So answer you can write, inside the loop the direction of the magnetic field is downward, and outside of the loop the direction of the magnetic field is in upward direction. Now come to the question number 2. The magnetic field in a given region is uniform. Draw the diagram to represent it. Remember students, the uniform magnetic field is represented only by the equidistant and parallel field lines. So this is the diagram. Now question number 3, it is asked choose the correct options. So 4 options are given, and the question is the magnetic field inside a long straight solenoid carrying current. So it is the answer, D option is correct. Why? Because the magnetic field inside the loop is always same. At the ends it is strong, at the mid it is less outside of the solenoid, but inside it is the uniform, because inside the solenoid the direction of the magnetic field is equidistant and parallel lines. So it is the uniform magnetic field inside. Now come to the next topic, force on a current carrying conductor in a magnetic field. So when you place a current carrying wire, current carrying conductor between a strong magnetic field, then it will experience a force. We can see it bends sometimes in upward direction, it may bend downward direction also. It means it experiences a force acting on it. This force is called the magnetic force, and the magnitude of this magnetic force is given by F is equal to BIL sin theta. It is the general formula. Here theta is the angle between the direction of the current and the direction of the magnetic field. B is the magnetic field strength, I is the magnitude of the current, L is the length of the conductor which is placed in a magnetic field, and F is the magnetic force. So this is the general formula to find the magnitude of the magnetic force. Now if you know the directions of B and I, then you can find the direction of force by using the Fleming's left hand rule. So see, what is the Fleming's left hand rule? If you stretch the first 3 fingers including the thumb of the left hand, then the thumb will show the direction of the magnetic force. Okay, and the first finger will show the direction of magnetic field, and the lower finger will show the direction of current. See, I am showing here, suppose this is the right hand thumb rule. So thumb will show the direction of the I am writing the F here. Okay, it is the direction of force. Thumb, just stretch the first 3 fingers like this. Okay, mutually perpendicular. Okay, like this, stretch all 3 fingers like this. Okay, so thumb will show the direction of force, the first finger will show the direction of magnetic field, and this finger will show the direction of the current like this. So F, it is the B, and it is the I. So this is known as the Fleming's left hand rule. Now after this we can discuss some block questions. Given page number 238. See the first question, it is the multi-choice question. which of the following property of a proton can change while it moves freely in a magnetic field? So when positive charge particle moves in a magnetic field, it will experience a force, so its velocity will change. If velocity change, then according to the formula momentum will also change. So options C and D both are correct. Now come to the question number 2. It is asked what will be the effect on the magnetic force when we increase the current, we increase the magnetic force, magnetic field, we increase the length of the conductor. So according to this formula, all are directly proportional to the force, so the magnetic force will increase in all cases. Now come to the question number 3. It is asked a positive charged particle, alpha particle, projected towards west. Okay, towards west. So this is the direction of positive charge particle. Positive direction is the direction of the current also. So we can take the direction of the current here in the west direction. And it is as projected west is deflected towards north. So this charge is deflected towards the force, towards the north. So in which direction it will be deflected? Where it will feel the force. It means you can say that in north direction force is there. Force is the direction. So now it is asked what is the direction of the magnetic field. So using the left hand rule, Fleming's left hand rule, you can find, just see I am showing again, force, this is the direction of force, and this is the direction of current. I am showing here. This is the force, thumb. This is the direction of the current. This is the direction of current. So this direction is the direction of the magnetic field. Okay, stretch this your 3 fingers like this. Okay, thumb in north direction. Okay, and this is the direction of current, west direction, and this is the direction of field. So this is the answer. Option D is correct. Thank you students. In next video we'll discuss about the electric motors.